Yo, I want to just keep listening to that music. That was like, I was like, oh, I was feeling that. Ooh. This is some non-copywritten music from YouTube, background music for chill gaming. I was like, I can feel it. Anyway, okay, so greetings, beautiful points of light. This is a beautiful mind. So this is gonna be, or AKA Mr. Pfeiffer. Let me turn this. I think it's okay. I feel like that. All right. So this is gonna serve as our lecture for this upcoming week for Calculus for Business. So we're gonna continue chapter 1. The main thing is just complete the assignments that you see on Blackboard. Um, so, anticipate, homework assignment with each section. I feel like my audio is still kind of high. Let me, um, yeah, you can anticipate assignments for each section and weekly quizzes and monthly exams, and that'll kind of get us all the way to the end. So exam 1 is about that last week of February, exam 2 is the last week of March, and exam 3, which is like the final exam, last week of April, first week of May actually, but that's kind of about how that works. Okay, so we're just going to continue where we left off. For this first chapter, we're doing about 2 sections per meeting. So I'm going to do my best to limit this to 35 minutes, 35 minutes a section, so that way we can honor our class time. So this comes from section 1.3, average rates of change. So the objectives here are to compute an average rate of change and to find a simplified difference quotient. Okay. So some definitions here. As x approaches a, the limit of f of x is L written. The limit as x approaches a of f of x is L, right? If all values of f of x are close to L for values of x that are sufficiently close but not equal to a. So remember, I think last time we were saying that the limit is concerned with being close to a point. Like when we're close to a point, like how does the function behave? As we get closer and closer to a point, are they approaching the same number or different numbers or any number in particular? Okay. So then we have this definition. It says the average rate of change of y with respect to x, as x changes from x1 to x2, this is going to be the ratio in the change in the output to the change in the input. So it's similar to slope, right? Slope is rise over run, which is change in y over change in x. So then you see that here, change in y over change in x. Okay. So a rate of change, average rate of change is essentially the slope between 2 points. Okay, so if we look at the graph of the function, we see that y2 minus y1 over x2 minus x1 is basically f of x2 minus f of x1 over x2 minus x1, right? So you have the rate of change from the point P to the point Q. So the change in our y values here over the change in our x values here, right? Which is both the average rate of change and the slope of the line from P to Q. The line through the points P and Q, which is this, is called a secant line. It's a secant line because it's going to intersect our graph at more than one point, right? Okay. We're doing pretty good on time. We're actually flying through this section. It's not going to take us that long. Okay. So this example, it says, for this function, find the average rate of change as x changes from 1 to 3, from 1 to 2, and from 2 to 3, okay? We kind of see a little bit of a hint there. This is page 7. I'm actually going to work this one myself. Let me see. So we got 1 to 3, 1 to 2, and 2 to 3 for x squared. Let me just get a copy of this. I don't need that one. I want it from here. Oh no, here we go. Okay, let me give myself some lines. I usually do better with like graph paper. Okay, so the slope, right? Average rate of change. Okay, so we just said that the average rate of change is going to be change in y over change in x, so that's f of x2 minus f of x1 over x2 minus x1, right? So let's get the ordered pairs. if we're dealing with f of x equals x squared, then let's do f of x1. In this case, that's going to be what? F of 1. It's going to be 1 squared, which is 1. And then f of x2, which in this case is going to, for this is part A, that's going to be f of 3, which is going to be 3 squared, which is 9, right? So now we're ready to plug in. So let's just get a copy again. F of x2 minus f of x1 over x2 minus x1. That's going to be, let's see, x2 is 9, x1 is 1 over, sorry, f of x2 is 9, f of x1 is 1. x2 is 3, and x1 is 1. Right? So it's going to be 8 over 2, which is 4. Okay. So we got an average rate of change of 4. Okay. So we'll check it momentarily. Let's go ahead and do part B. It says, oops, x changes from 1 to 2. Okay. To 2. Okay. So let's do the same thing. So our f of x is x squared. Our f of x1, which is going to be f of 1, we don't really, that's kind of a repeat. Okay. F of x2, x2 in this case is what, 2, so that's going to be f of 2, 2 squared. 2 squared is 4. Okay. Let me just go ahead and add another page. Okay. So then the average rate of change, which is f of x2 minus f of x1 over x2 minus x1. This case, that's going to be what? 4 minus 1 over 2 minus 1, which is 3. Okay. And then C, as x changes from 2 to 3. Okay. So then we're still working with f of x equals x squared. F of x1 in this case is going to be what? F of 2. So that's going to be 2 squared, which is 4. F of x2 is going to be f of 3. 3 squared, that's not a 3. 3 squared, which is 9. So then the average rate of change should be what? 9 minus 4 over 3 minus 2, which is 5. Okay. So now, let's compare. All right, so let me see. The first one we got 4, then we got 3, and then we got 5. We're going to compare that to the pre-typed note. So then for A, and let's do like this, paper, they got 4. I think we got that same result. And then we got 3 and 5. You see the 3 and you see the 5. Okay. You see my time. Good. Took about 10 minutes. We're looking okay. So, quick check. It says state the average rate of change for each situation in a short sentence. Be sure to include the units. It rained 4 inches over a period of 8 hours. So inches per hour. So half an inch per hour. So the average rate of rainfall was half an inch every hour. Half an inch of rain every hour. Okay. Car travels 250 miles on 20 gallons of gas. So miles per gallon. So 250 divided by 20, that would be what, 5, 10, 12.5? 12.5 miles per gallon. So the average mile travel on a gallon of gas was 12.5 miles every gallon. Okay. At 2 p.m., the temperature was 82 degrees. At 5, it was 76. So you had the degrees per hour, right? So 82 minus 76 over 5 minus 2. So then the temperature dropped by 2 degrees every hour. Average change in temperature was 2 degrees every hour. Okay. Not too terribly bad. Quick check. Okay, find the average rate of change between these. Okay, let's go ahead and do it. I'm just trying to think if I'm going to run out of time. Let's just go ahead and do it. So I'm going to get rid of this. I want it from here to here. This is there. There it is. And like this. Okay. All right. So okay, so average rate of change again. Change in y, so f of x2 minus f of x1 over x2 minus x1. Our f of x in this case is x cubed, okay? Okay, so then let's find f of x1. In this case, for part A, it's going to be what? F of 1, which is going to be 1 cubed, which is going to be 1. F of x2, in this case, is going to be f of 4, 4 cubed. 40, was it 64? Yeah, 64. All right. So then, let me just copy and paste this. I don't feel like writing this again. Copy, paste. So the average rate of change is going to be 64 minus 1 over 4 minus 1. 63 over 3, 21. Okay, that's fine. For part B, f of x1, I think it's still going to be 1. And then f of x2 is 2, okay. So there's going to be f of 2. 2 cubed is 8. So then this, average rate of change between these 2 points is going to be 8 minus 1 over 2 minus 1, which is 7. Okay. Let me add some paper. And then part C is as x changes from 1 to 1.2. So notice that second point is getting closer and closer to the first point. First, the second point was at 4, then it was at 2, now it's at 1.2. So that second point is getting closer and closer to the first point. So notice that our average rate of change, it seems like it's approaching some number. Okay. So I think the first thing kind of stays the same. I'm just going to copy and paste because I can copy, paste. So I think the f of x1 stays the same, and then f of x2 saying it's going to be f of 1.2, 144. Oh, nope, that's not right. Totally not right. I did squared. I don't know, 12 cubed. 1.2 cubed. Hey Siri, what's 1.2 cubed?
1.2 raised to the third power is 1.728.
728. Okay. So then copy, paste. Average rate of change between these 2 points is going to be that 1.728 minus 1 over 1.2 minus 1. Okay. So that's going to be 0.728 over 0.2. So 0.2 is the same as what? 2 over 10. So then that's going to be the same as 7.28 divided by 2. What is that? 3, 6, 4. Let me see. Hey Siri, what's 0.728 divided by 0.2?
0.728
Okay.
divided by 0.2 is 3.64.
Okay. So, all right. So we got 21 and then 7 and then 3.64, right? And let's switch our view back to single page. And let's do paper like this. So I think we got the 21. You see that one there? And then this is the work that we did. And then you see the 7 and you see the 3.64. Okay. So hopefully that was okay. So what we're doing is basically finding the slope between 2 points. That's all that we're really doing. Oh, they're doing a candy jar contest. I kind of want to take a picture of it and do a quick calculation and see. It kind of worked. We did one place I was at, and it kind of worked. Like you can like do an approximation, like get a sense of the size and do a quick calculation to see. Anyway, all right. Let me see my time. Okay. So the average rate of change of f with respect to x is also called the difference quotient, right? It's given by this formula here, f of x plus h minus f of x over h, right? So in the previous one, we were looking at the slope between 2 points, the change in y over change in x. So now what we're doing, say we have some point x comma f of x, right? We just have a point. And then we want to consider a second point, like if x is going to be our first point, then we want to consider some change. So h is just a change. So if x1 is just x, then x2 is going to be x plus some change, some difference, right? So then if we have this x, we can have f of x. If this is going to be x plus h, then we can have f of x plus h, right? So then if we said y2 minus y1 over x2 minus x1, if you say x plus h minus x, you're left with just h, right? So that's where this notion of the difference quotient comes from. This is just another expression that we use. It's still talking about slope between 2 points, right? The difference quotient is equal to the slope of the secant line from the first point to some second point where we have a change in x, right? H is just a change in x, okay? All right. It's just another articulation of the same thing. So for this, find the difference quotient for A and B. Okay. Let me give myself some space. Looking like we might run out of time. We'll do the best that we can. So we got to right at about 10 minutes. I'll do whatever I can in 10 minutes, okay? Let me go. This is fine for now. Difference quotient. Let me just get a copy of this. we're ready to rock and roll. Okay. So difference quotient. If we're going to do this difference quotient, let's start by writing out the difference quotient. Difference quotient goes f of x plus h minus f of x over h, right? So we have our f of x. Let's go ahead and find f of x plus h. Let's just do that off to the side by itself. I'm going to do it in green. Let me think about it. Oh, this one is different because they actually gave us values. Okay, this one's actually a little bit easier. Okay, I'm just going to actually plug in. Let me think. So this is going to be f of, let's see, x is 5, h is 3, f of x is 5, and h is 3. Okay, well, let's go with it and see what happens. So that's going to be f of 8 minus f of 5 over 3. So 8 squared is going to be 64 minus 25 over 3. If there were 30, that would be 34, so 39 over 3. I think that's a 13. So we got lucky here. They gave us the difference quotient in the x, right? So we're going to do that. That should be part A. And then part B, so our x is 5. Our h is, so now our change is 0.1, so we're doing a smaller change. Still minus f of 5. And our h in this case is 0.1. Okay. So 5.1, I don't know 5.1 squared. Hey Siri, what's 5.1 squared?
5.1 raised to the second power is 26.01.
Minus what, 25 over 0.1? So that's what? 1.01? 1.01 divided by 0.1. 0.1 is what, 1 over 10? So just multiply by 10, so 10.1. Okay. 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 So yeah, we got a little bit lucky there because we got just about 10 minutes remaining. They gave us a lot of these values. Okay, let's go here to paper. So the 13 looks good and the 10.1. I think that's what we got, 13 and 10.1. Okay, let's go on to the next one. Let me see. We're so close. For f of x equal this, find a simplified form of the difference quotient. Okay, so again, generally the difference quotient is f of x plus h minus f of x over h. Okay. Let's see. So we have our f of x. We need to expand. Let me see if we have x plus h. Okay. So I want to just focus on f of x plus h. I want to focus on that term, right? So in this case, it's going to be x plus h cubed, right? Cubing a polynomial. So then that's going to be x plus h times, we're going to have x squared plus 2xh plus h squared. Then we need to distribute again. Let me see. That's going to be x cubed, x squared h, 2x squared h, 2x squared h, 2xh squared, 2xh squared, and then h cubed, right? So if we combine like terms, we get this. We got x squared h, so that becomes 3x squared h, xh squared. I think I missed a term. Let me see. X times x squared is x cubed. H times x squared h, okay? That's going to be 2x squared h, and we should also have a 2xh squared. Okay, that looks good. x, okay, I found the missing one. So the missing one is here, that last term. It's supposed to be xh squared. Xh squared plus h cubed. Okay. So then that's going to be a 3xh squared and then h cubed. Okay. So we expanded out the f of x plus h. We expanded that by itself, right? Okay. Seamless. Okay. And let me do some lines. Okay. So that last line in the green is the expanded form of that first part of this guy right here. I'm switching the color to green. Okay. And then let's put all this together now. So then this, let's just copy. Copy. So then this is going to be basically this guy right here. Copy. This is the last line of that green portion that we just did. Okay. Minus f of x. So f of x was x cubed. And then we're going to say all of that divided by h. Okay. So if we do this, the following happens. This is canceled by this, and I think all the remaining terms still have h in them. So we can factor out a h from the remaining terms. So if we factor out h from the top, that's going to leave us with 3x squared plus 3xh plus h squared. We're still saying divided by h. These cancel, and I think this is the final result we were looking for. 3x squared plus 3x h plus h squared. Okay. Let me check the time, because I'm pretty sure we're just about out of time. We got a little over 5 minutes. Let me see what I can do in 5 minutes, okay? We'll go to paper like this, and let me do view, seamless, single page. All right, let's compare it to what they got. We got 3x squared plus 3xh plus h squared. 3x squared plus 3xh plus h squared as long as h is not 0. Okay, I think we're okay. Okay. Calculate the slope of the secant line at x equals 2 for these 3 points. I'm going to leave that as an exercise because we're pretty much out of time. Okay, but you can see where they took that long expression that we got and they plugged in those different components. Find a simplified form of the difference quotient. I'm going to have to leave this one as an exercise as well. It's definitely going to take me more than 5 minutes, and I don't want to get into it. Let me just see if there's anything else that's pertinent. Okay, and that's a section summary. So average rate of change is the slope of the line between 2 points. So y, the change in y over change in x, which is y2 minus y1 over x2 minus x1. If the 2 points are solutions to a single function, then an equivalent form of this can be expressed as this. Right? This is called the difference quotient. Right? So f of x plus h, remember h is just some small change in x, right? So f of x plus h minus f of x over h. Okay. The difference quotient is the same as the slope formula. Both give the slope of the line between 2 points. The difference quotient gives the average rate of change between 2 points on a graph represented by the secant line. It is preferable to simplify the difference quotient algebraically before evaluating it for particular values of x and h. Okay. All right. So I think that concludes this section, and that put us right within our 35-minute time limit that we were targeting. So, as you do the best you can, as you make your way through this lecture, take notes as if you're in class, write down your questions. And on that note, we're going to end the session here. And for one beautiful mind to another, enjoy the rest of your day. Peace.